So this is 2.5, which is literal equations and formulas. Oops, I didn't write our number. 2.5, literal equations and formulas. And like I said, this is beautiful because you've done it. You just haven't done it with all letters before, or mostly letters. So a literal equation just means that you're going to have two or more variables. Okay, normally we've been solving for one variable. So it's like solve for x, and you solve for x and you get x equals something, right? And you get a number as your answer. Today, you're not going to get numbers as your answers for a majority of the problems. You're going to get a new equation, okay, a new expression. So let me just give you an example of what you're going to be seeing here, and then we'll do a few. Let's say I gave you 10x plus 5y equals 80. And I said x is pizzas, and y is sandwiches. Okay. If I said, how many sandwiches can you buy if you buy 3 pizzas? Okay, so they're saying it's $10 a pizza, it's $5 a sandwich, and the total that you're spending is $80. Okay. If I buy 3 pizzas, how many sandwiches can I buy? If I buy 6 pizzas, how many sandwiches can I buy? Well, rather than plug in 3 for x and 6 for x right here, right now, you'd have to do a lot of solving twice, right? Whereas if we just solve it for our y, then we're plugging in something for x each time where we don't have to solve, we just have to simplify. We just have to reduce, okay? So if this is my starting point, 10x plus 5y equals 80, I'm going to solve for y. I'm going to solve for sandwiches to make life easier, okay? So let's think about that. If I want to isolate y, what's the first thing I need to get rid of? The 10x, right? How do I get rid of that from the left side of my equation? We're not going to divide it. Here's the thing. 10 times x, yes. If I was trying to get rid of the 10, I would divide. But I'm trying to get rid of the 10x, which is being added to the 5y. We're going to subtract it. It's positive right now. We're going to subtract it. So your first step is going to be take away a 10x from both sides. Okay, and here's where I see a lot of mistakes. What is 80 minus 10x? It's 80 minus 10x, right? Those are not like terms, okay? This is where this lesson can be a little bit of a challenge because you're not really simplifying a whole lot, okay? You're just kind of rearranging more. So the 10x is gone from this side. What you're left with right now is 5y equals 80 minus 10x. We can't simplify that any further, right? We cannot combine 80 and 10x. Now, again, we're trying to isolate y. So what would my next thing be? How do I get y by itself? Divide by what? Divide by 5, okay? So now if I divide by 5 everywhere, and you have to do it to everything, I'm going to divide by 5 on all of these. Okay, so this is gone. 5 divided by 5 is 1, so I'm left with here is y. Can I do 80 divided by 5? Yeah. 80 divided by 5 is, what does that come out to? 16. Then we're subtracting, minus, okay? Can I do 10x divided by 5? Yeah, right? 10 divided by 5 is 2. And we just keep the x with it, okay? Now here's the beauty. We said if we bought 3 pizzas, how many sandwiches could we buy? If we bought 6 pizzas, how many sandwiches could we buy? Well, here's our pizzas, Okay, this is the number of pizzas we have. So all you have to do now is say y equals 16 minus 2 times 3. And now you just have to compute with math. Okay, 2 times 3 is 6, so 16 minus 6 gives you 10. So if you did 3 pizzas, okay, you would get y equals 10 sandwiches. So if you bought 3 pizzas, you could buy 10 sandwiches. But what if I bought, okay, so now we're going to come back up to this equation, y equals 16 minus 2x. What if I bought 6 pizzas? What do? Multiply by 6. Plug the 6 in for x. So y equals 16 minus 2 times 6 would be 16 minus 12, which means we can buy 4 sandwiches. Jayla. In the problem, I just said, what if we bought 3 pizzas? So I gave you the 3 as the number of pizzas, and x was our pizzas, okay? So for 6 pizzas, you could buy 4 sandwiches. For 3 pizzas, you could buy 10 sandwiches, okay? So it's just working through those. Kennedy, put your iPad away from me, please. Ryan, iPad away. Away. I don't want to see them on your desk because you seem to keep turning them back on after I ask you not to play with them. Kennedy, off your desk. Questions on that? Okay, this next one's a little bit different. This next one, you don't have any numbers. Here's what it looks like. Let's say we have ax minus bx equals c, and they say solve for x. Okay, so we want to isolate x. Now this one's tough. You're doing the distributive property in reverse. Does anyone see what you would do to get x isolated? Subtract them. How do you do that? You could think of it as invisible ones. Tell me how you would do this, okay? Let's say I plug in numbers for a and b. Let's say it's 2x minus 1x equals c. What would you do here?
Minus them.
Minus what?
2 by 1.
2 and 1, right? Okay, so think of it like that. Let's think those are our numbers, but now we replace them with a and b, okay? The way we simplify it is we say a minus b, right? 2 minus 1, a minus b. So you're going to take this and you're going to do a minus b, but we still multiply it by x. Do you see how that's the reverse of the distributive property? If I were to distribute this right now, I'd get ax minus bx, which is what we started with, okay? So I get a minus b times x equals c. If we want to isolate x, we want to get x by itself. Do you see what you would do next? What are we doing with x and the a minus b? Are we adding, subtracting, multiplying, dividing? What are we doing? With this term
Same.
and this term.
I'm confused. You said
Okay, let's finish this one and we'll do another one just like it. What are we doing between these two? We're multiplying, right? If you put parentheses, we're multiplying those, okay? So if I'm multiplying right now and I want to get x by itself, what's the opposite of multiplying? Divide. So we're going to divide by a minus b on both sides, okay? So you're going to get this canceled. Oops, a minus b divided by a minus b is 1, right? You're left with x equals c over a minus b. Okay? Okay, we're going to do another one just like it. No. Let's say we have dx minus px equals g. Okay? Think of it with numbers. 5x minus 3x equals g. You want to do, if it was 5x minus 3x equals g. No, but that's what I'm saying. Look at what you would do right here. You would do 5 minus 3 is 2, and then you'd multiply by the x, right? Okay, so what we're going to do instead, because we don't have numbers, we have variables, we're going to do d minus p, just like 5 minus 3, right? So we're going to do d minus p, but because that doesn't simplify, we're just going to put parentheses around it and multiply it by x.
When you do that, when you subtract it, what would you get? Like,
You don't. You leave it like that. You leave it as d minus p, because we can't, right? We don't know what they equal. So we have to just subtract it.
D minus p equals q.
Yeah, that's not true, though.
It could be true.
It could be, but it's not. All right, so if it looks like this, Kennedy, be done. If it looks like this, what do I do next? We don't want to go back to distributing, though, right? We're going to get rid of the d minus p. So right now we're multiplying it. We're going to divide by d minus p and divide by d minus p. So this is going to cancel. D minus p divided by d minus p is 1, right? So all I'm left with on the left is x. On the right, then, I have g over d minus p. None of that can be simplified, so this is your final answer. They're just saying solve for x. So isolate the x, that's what you get. Okay? Let's do another one. It'll look a little bit different than that, but same idea. Just so you know, on page, I'll write this down so you can see it. On page 272 in your book, okay, there's a list of all kinds of formulas. So if they're asking you about something and you don't know the formula for it, chances are it's there. Okay, so keep that in mind. Maybe write that page number down so you know what you're looking for, 272. But there's a whole bunch of formulas there. But let's say example 3. We're talking about circumference of a circle. Do you know what circumference of a circle is? So it's like the perimeter of a circle, right? Okay, so here's the formula. Circumference equals 2 times pi times the radius. Okay? If I said, what's the radius of a circle if the circumference is 64 feet? Okay? So circumference is 64. Find the radius. Well, the easiest way to go about it is to solve for r and then plug in the 64 where you know it goes. But we have to figure out how do you solve for r in that problem. What are we doing with the 2 and the pi and the r? You're multiplying, right? Okay, so if I'm multiplying 2 times pi times r, what do I do to get rid of them? The opposite, you divide, right? Okay, so we're going to divide by 2 pi, which will cancel this out. And then whatever you do to one side, you have to do to the other. So divide by 2 pi over here. So your equation right now is this. R equals C divided by 2 pi. Okay, well, they told us C is what? 64. So I'm going to take that 64 and I'm going to drop it in right here. So what I'm going to plug in is 64 divided by 2. And another number for pi, does anyone know the shortened number for pi? 3 point, you guys are so smart. 3.14. Okay, so you're going to multiply this first, because remember, this is like division bars like parentheses. So 2 times 3.14, you get 64 divided by 6.28, and that should be your radius. So you plug that in. 64 divided by 6.28. And if we round that, that radius is approximately 10.2. That was given to in the problem. We said the circumference is 64, find the radius. So you want to first solve for R, and then you can plug in C. Okay? How are we doing? Okay, here's one more of these. And then we'll see if you have any other problems you want to go through. It says a group of monarch butterflies migrates 1,700 miles in 120 days. Okay, so they go 1,700 miles in 120 days. What is the average rate in miles per day? Do any of you know distance equals what?
Distance equals distance over time.
Speed times
No,
speed times
Distance.
starts with a T.
times
Time, right? Distance equals the rate times the time, okay? And again, you don't need to remember that formula. They will give you the formula, or the formulas are all on that page number I gave you, okay? But D equals R times T. Well, let's think about that. They're asking, what is the average rate? So what variable are we trying to isolate? If we're trying to find the rate, what variable is that? That's R, right? So we're trying to get R by itself right now. What number represents D right now? Distance.
120.
1,700 miles is our distance. What's our time? 120 days, right? Okay, so what we're going to do is we're going to solve for the average rate. We're solving for R. We want R by itself. How do I get R by itself right now? You divide by what?
R and R with a D. I can't.
We want R by itself. So we want to leave R. We want to get rid of T. How do I get rid of T? Divide. We're going to divide by T here and divide by T here. So this cancels. T divided by T is 1. You get the rate equals the distance divided by the time. And isn't it convenient that we have the distance and the time, right? So we're going to say the distance is 1,700 divided by the time, which is 120. And that should be our average rate that a monarch butterfly is traveling at. So you just take your calculator, 1,700 divided by 120, and you get 14.2. So your rate is 14.2 miles per day. Okay?